carefully. Yes, it's the potential energy gradually changes into kinetic energy. The total sum of both the energies, the potential and as well as the kinetic energy remains same. It's the kinetic energy gradually changes into potential energy. The total sum of the both the energies, potential and kinetic energy does not remain same. I hope you got it. There is a one body is a falls from certain height. This is a particularly contained at some particular height. It is the h. Okay, clear? And as well as from this particular height, the fall towards the end. And here, what here? Yes, there is a already discussed in the conservation of mass. Yes, there is a what actually contained is at particular this position potential energy is a height that is equal to mgh. The mass of the body m, acceleration due to gravity is the g, and the height is the h. The potential energy is the become what here? The potential energy is the become mgh. Here, kinetic energy is the become 0. Why? Because you know very. Why? Because there is a velocity become at starting position. That's why there is a kinetic energy 0. Here already we are discussing potential energy is the become mgh minus mgx. Okay, from here to here the distance is the x. Okay, clear or not? And here it is become mgh minus mgx. And the kinetic energy is the become here mgx. Based on a traveling distance and v square minus x square based on that formula, we are considering mgx. Okay, like this. That is what we are considering kinetic energy equal to half x square. And here v square minus c square is equal to 2ax. That is only plus 2gx. And now here it is also as v square is equal to taken as what 2gx. Now this value substituted here, what will we get? Half into m into 2gx. This one and this one cancel. Now it is called mgx. The kinetic energy at the mean position, or otherwise somewhat a. Here the point a. Okay, at that time it will become mgx. Got it up? Now that whatever the potential energy here it is the type of surface, that is why it is 0. The kinetic energy will become mgh here. The same in this way only we have to consider. Yes, in the place of x we have to write h. We'll get the answer here mgh. Okay, once there is a kinetic energy, potential energy, the varied here. Got it or not? Here there is a one place to another place, kinetic energy and as well as the potential energy, the varied here. Yeah. Here, how we consider this mgh? This is mgh minus mgh. Mgh everywhere the total energy remains constant. Once here, when a body falls from certain height, okay, it's a potential energy gradually changes into kinetic energy. Yes, it's a correct only. The potential energy is a decreasing, kinetic energy is increases. It is a changes. The answer A is the correct only. The total sum of both the kinetic energies and potential energy remains same. Yeah, everywhere the energy of this body become mgh. The sum is become mgh. The sum is become mgh. Here. Wherever you consider from this path A, B, C, suppose you are consider A to the B to the C. Where so there is a yes, there is a total energy remains constant. The B is also correct. The total energy is a mgh. Okay, and next. After this, the kinetic energy gradually changes into potential energy. No, it is potential energy is the changes into kinetic energy. Here, kinetic energy not changes into potential energy. Yeah, got it. I see the wrong here. And next, the total sum of both the energy. How? Yes, and here also I've given this is the potential energy and this is the kinetic energy. It's particular point at where at a starting point. At the starting point to the up to C, whatever the flight mode it is there, the body content and total energy remains mgh, total energy mgh, kinetic energy plus potential energy. Okay, got it? Wherever mgh, here also mgh only, but meanwhile there is a potential energy is decreasing, kinetic energy is increasing. Why? Because height is decreasing, position is decreasing, velocity is increases. Like, got it? Yeah. This is only answers A and B. Next, sixth question. As a stone is thrown vertically upward, a stone is thrown vertically upward, it comes to rest. Yes, momentarily at the highest point. What happens to its kinetic energy? A stone is thrown vertically upward, it comes to rest momentarily. Yes, at the highest point. What happened to its kinetic energy? It's a convert into electrical energy. It's a convert into potential energy. It's a convert into chemical energy. Its velocity becomes zero. Yes, it come to the rest momently at the highest point. What is the happens with kinetic energy? The same manner we are consider. Okay, here there is the initially there is a velocity you have to provide, and finally it will be comes to the rest. Area kinetic energy become zero here. Okay, clear or not? And what the options are given? It's a convert its electrical energy. No, it is not a correct. It's a convert into potential energy. Yeah, it's a convert into potential energy. Yes, its a velocity becomes zero. When it is a comes to the rest at highest point, its a velocity becomes zero. That is only called maximum height. We already discussed it. There is answers have become what? The answers have become B and as well as the D. Here, energy, according to the conservation of energy, the energy forms are may changes. Chemical energy to the kinetic, chemical energy to the light energy to the chemical energy, electrical energy. Like that, it will be changes. Forms of energies are changes from one form to the another form. Okay, now yes. Mechanical energy convert into electrical energy. Electrical energy convert into light energy. Light energy may convert into okay now heat energy. Like that, one form of energy is a changes into the another form of energy. There is no doubt at all. Okay, clear or not? But there is it is not changes from kinetic energy to the chemical energy. There is some kinetic energy, sometimes a part of a chemical energy. Okay, clear or not? Sometimes the potential energy is a part of electrical energy may be depending on the charge position like that. But it is not changes into kinetic energy to the any other form of energies. These is the kinds of energies. Got it? This is only we are considered according to our conservation of energy. There is whatever the body is we are projected like this. The chalk piece is moved like this. When it will be reaches to this highest point, its velocity becomes zero. Yes, from year to year, the kinetic energy gradually yes, here convert it into potential energy, gradually decreases. Why? Because gravitational force is attracting the body in downward direction. Got it? This is only the sixth answer. Next is seventh answer. Yeah, the math of following are given. One second. The column one, the whatever given A, B, and as well as the C, and as well as the D. Yeah, movement of a body increases to movement of body increases to x times. If the kinetic energy of the body increases to x times, if the yes, the bodies have the same kinetic energy and as well as the work energy theorem. You know very well the movement of a body increases to x times. If the kinetic energy increases to okay, movement increases to under root x times. Yes, ratios of their movement Yeah, there is a V R. When the kinetic energy of the body increases to x times, the momentum increases to under root x times. You know very well how it is. Okay, the relation, the kinetic energy, the momentum is taken as what? Actually, yes, the momentum, the directly proportional to under root k. Okay, clear or not? That's why it is increased by a times or x times. Here we are taking here x times and increases. It is also under the x times increases. Yesterday we are discussed one problem, and here we are taking that is answer is the Q. Okay, clear. Next, see one second. If the two bodies have the same kinetic energy, yes, and here initial kinetic energy minus final kinetic energy, that is not that half mv square minus half mv square. That is the work energy T. Okay, now that is the word W is equal to, okay, half mv square. It is the final kinetic energy. It is the initial kinetic. Final kinetic energy minus initial kinetic energy is only called the, yes, work energy theorem. Yeah. Next, one more given here. The ratios of their momentum, momentums of the body increase into the x times. The kinetic energy of the body is increases to x square times. Yeah, yesterday we already. This is the relation, whatever we consider. What is kinetic energy? 1 by kinetic energy 2 is equal to p square. P1 square by P2 square. Okay, this is only the they are considered. Indirectly, it is also written as. Okay, what we have to write? P1 by P2 is equal to taken as under the root of kinetic energy 1 by kinetic energy 2. Got it? This is only we are. Yeah, next here, see, if two bodies have the same kinetic energy, yeah, actually there is a velocity may increases to x square times. That will be not a given. Answer is taken as somewhat of, okay. P is answer for it. This is only the answers we are considered for it. Okay. Yes. A is match with the R, B is match with the C, match with the P, D is match with the T. Yes, please note down it. Now, please change the question. If the velocity, if the velocity of the body increases to x time, B question. Answer B question. Okay, yeah. Yes, B side question is how to change it is. Yeah. Next, eighth question. Yeah, a body of mass 4 kg is moving with a momentum of a 12 kg meter per second. So kinetic energy is what? A body of mass 4 kg. A body of mass 4 kg is moving with the momentum of a 12 kg meter per second. Its kinetic energy is what? Yeah. What is the kinetic energy? Mass m is equal to taken as 4 kg. Got it, Azra? And also moving with the momentum. How much the momentum is there? The momentum m is equal to pv. So p is equal to taken as mv. That is equal to taken as how much? 12 kg meter per second. And here, what is the kinetic energy? Simple question only. We have to find out velocity from it. Okay. Here, what is the momentum? 12. And what is the mass? They give 4. Okay, clear or not? What is the V? We don't know here. V, which implies V is equal to taken as V is equal to taken as we are what? 12 by 4. That is 3 meter per second. Got it? Now, kinetic energy is equal to what? Half mv square. Half mv square. As half into m is a 4, v is about a 3, square it. And now the two cancel with each other. 2 into 3 square. That is become what? 2 into 9. It is a 18 kilojoules. 18 joules here. Sorry, 18 joules. Answer is become 18 joules. Eighth question answer is 18 joules. I hope you got it here. Simple question only. First they are given not directly the velocity. Yes, and the velocity you have to take here from the given data. All the students, listen carefully here. And this is about our component and extra components are also there. And here there is a different questions are given. Extra is the extra component. And once you try your level this extra this. And if it not hit, please give the message to me. In the next class, we are going to discuss there is circular motion. Before going to that lesson, there is a whatever these kinematics lessons we are discussing here now. That is the work, power, and as well as the energy. So very important. Once recall all the component whatever discussed it. The work is equal to W is equal to F into S. Okay, that is Fs cos theta. We already discussed it. Which one is called a work and how the work is done. That is everything we already discussed. W is equal to F into S cos theta. Yes, when there is a negative work, when it is a positive work. Okay, clear or not, all the students? When it is a positive work, when it is a negative work, that all the things are important. Yes, you already discussed it. Already we have discussed the force and as well as the displacement vectors are in our same direction. Okay, now the work is become maximum. Okay, now other than opposite in direction, there is work is become negative. Got it or not? Uh, yes, I hope you got it here. There is a whatever our component we are considered for the work and as well as the work power and as well as the energy purpose. In this one, there is a which one is a called negative work, which one is a called a positive work. Yes, and as well as when we are considered perpendicular manner, one work is force component is a perpendicular to the yes displacement component. It is a called what? It is a called as what zero work. There is no work. When we are considering a circular motion, there is also zero work. Got it or not? Like that, there is about a works we are discussing. Next component here, we consider one more thing. What is that? What is that component here? We consider next. There is a power. Power is nothing but what work by time. Okay, clear or not? There is a work by time or force into velocity. It is also called the two formulas are there. One is the force into velocity. Another one is here we consider as a work into power is equal to work by time. That is also we are considered. Next one is energy. Very important concept in your class level. Okay, work, power, and as well as energy. One is interrelated with another one here. Energy is nothing but capacity to do work. Capacity to do work. Okay, clear or not? This is only we are considered here. Yes, and which one is called capacity to do work here? Okay, yes, that is only called energy. It is in a two ways are there. One is the potential energy, another one is a kinetic energy. Which one is called kinetic energy? Which one is called potential energy? The kinetic energy is nothing but the energy virtue of its motion. Potential energy is nothing but the energy virtue of its position. Got it? Or there is a both they are considered. Energy virtue of its motion, energy virtue of its position. Okay, clear or not? And work energy theorem. Whatever the energy differences are there, kinetic energy differences are there, that is equal to okay. Yes, yeah. What is final kinetic energy to the initial kinetic energy? That is a called as here. What it is? It is a called as work energy theorem. Okay, and as well as one more important component that is a conservation of energy. Which one is a called conservation of energy? The energy is not created by us. Energy is not destroyed by us, but energy is changes from one form to the another form. Okay, that is only called what? That is a called as conservation of energy. Okay, already now today we are discussing now fifth question based how there is a we applied a conservation of energy. When we throw the body, the velocity gradually decreases. When we are freely for the body, the velocity gradually increases. When the velocity increases, then the kinetic energy also increases. We have taken so many relations. Okay, so many relations for the whatever the kinetic energy and as well as the potential energy. Got it? Or yes, what is the relations we have considered? The kinetic energy is a directly proportional to velocity. The kinetic energy is a directly proportional to the mass also. Okay, and as well as there is a momentum is a one of the component is also important for the discussion of kinetic energy. The momentum terms K kinetic energy, the terms of momentum written as T squared by 2m. Okay, from this equation, you get the relation between the momentum and as well as the kinetic energy of the body. So these all the concepts are very, very important. Based on these concepts interrelatedly, we are taking the whatever the distance traveled by the body, when we applied a kinetic energy this much, how much distance is traveled by the body. Okay, as and as well as how much far it will be traveled, how much long it will be traveled in the our whatever the edge questions it will be there, extra edge questions it will be there. Once solved it. Okay, if you have any doubts, please discuss later. Okay, yeah. This is today's our class. In the next class, we are going with the circular motion. Okay, thank you.